are written on the bottom of page 197. So. Remember that one? So if I had, like, for example, log of 3x, that would be the same thing as log of 3 plus log of x. Well, you can break them apart, but you can put them back together again too. So, in other words, if I had log of, whatever, 4 plus log of 5, that would equal log of 20. So you just multiply those things. Now this only works if they're the same base. So this would be the common log, base 10. But if they're the same base, this is going to work. Alright, so guess what this one is then. Not you. Would you stop talking? I swear, every time I turn around. Okay, anyways, yeah, so it's subtraction. And then the last one, I feel like this one, let's see, alright, let's do, I guess this. You guys remember what this one was? It's supposed to be an exponent. Did you guys get that? You can bring the exponent down in front as a multiplier, a factor. But it works both ways. Like if you have a number in front, you can move it up to the exponent also. And I think they're going to ask us to go both ways. So if you subtract, you can just put this divided by that. Laws of logs. Yeah, I skipped law of 3. It's kind of a duh statement though. Maybe I should, well, we'll probably use it on a few problems, so I guess I'll mention it. If I had like log of 2x equals log of y squared, you know what I know?
Y squared.
Yeah, 2x equals y squared. Okay, because 10 to the y equals 2x, 10 to the y equals y squared. If these things are equal, then these things have to be equal. Yeah, anyways. Yep. That one I don't think we probably need to remember as much as these 3. Although we will use that a few times, it's just maybe a little more obvious. Alright, here we go. So on number 1, write each expression in terms of m and n. Basically what that means is they want us to break it apart. And then on number 7, when we get down there, they want us to put it back together again. So we're just going to kind of practice manipulating. So, what can I do with the 2? Put it on the front, yes. The exponent can go down there. That was law number 3. What can I do with the m and the n? Break it into 2. Now, what do I do with this 2, though? Put in front of both of them. It's 2 times everything, so it really should go in front of both of them. Or I could have like thought of it like this, like the 2 goes in front of both of them because it's on both of these. The book actually wrote it like this, 2 times, and then they split up. So log of m plus log of n. 2 log of n plus 2 log of n. That was law number 1. Number 3. Alright, we're stepping in the muck already. Log cubed root over n. Okay, before we do anything, let's turn that cubed root into a rational exponent. Let's turn it into an exponent. If I have the cubed root of m right here, that's m to the what power? And this would be n to the what power? Negative 1/3, because it's on the bottom. So I could rewrite this as log of m to the 1/3 n to the negative 1/3. Oops. I could have left n on the bottom and called it positive 1/3. That would have worked also. That might have been less confusing, actually. Maybe, I don't know. So anyway, we're going to split them up just like this one. Log m to the 1/3, log n to the negative 1/3. But the exponent's going to go here. I'll just split it. I'll do it one step at a time. But then we're going to move the exponent out in front. So it's 1/3 log m plus negative 1/3 would just be like minus 1/3 log n. I wonder if the book just put 1/3 in front of everything. Yes, they did. That's okay. Let's leave it alone. Number 5. Alright, this one looks easier to me. Okay, what's another way of writing square root of n? N to the what? So it's going to be log of m squared plus log of n to the 1/2, but then the exponents are going to move to the front. Can I skip a step? Okay, I'll do it the long way. And then the exponent moves to the front. Did I copy this wrong? No. You guys had looks on your faces like I did something wrong. Any questions so far? Good to go. Number 7. Okay, so write each expression as a rational number or as a single logarithm. So we're going to combine everything together into one log. All right. Luke, any ideas? How can we squish these together? No, can't add them. So up here, we were doing m times n, and they spread out to log of m plus log of n. So if you want to go the opposite direction and put them back together, they turn back into times. Does that make sense? So, go back to my first example. Oh, I erased it. Never mind. My first example was, Okay, so basically, if you want to add the logs together to make it one log, you just have to multiply those two numbers, a times b, together. So in this case, we have three numbers though. So it's just 2 times 3 times 4. Common log of 24 is number 9. What are we going to do with that 1/2 on number 9? The thingy. Exponent. Yeah, the 1/2, the factor out in front, can move up to the 9 as an exponent. And okay. What is 9 to the 1/2? 3. It's like the square root of 9. So I got log base 6 of 3 plus log base 6 of 5. So again, just multiply them together. 3 times 5. If your answer simplifies, you should, but like if this had been 36, for example, well, 6 squared equals 36, so this would just turn into a 2. But most of the times, it doesn't simplify very nicely. So we'll just leave it like that. Ooh. 6 to the 1 is 6. 6 to the second is 36. So on number 11, the 2, again, is going to move up as an exponent. So it'll be natural log of 6 squared minus natural log of 3. Now we haven't done a minus yet. What do we do with the numbers in there when we're subtracting? Divide. So on 9, we were adding the log, so we multiplied the numbers. So if you subtract, you divide the numbers. So what is 6 squared actually? 36 divided by 3, here I'll just write it all out, equals natural log of 12. If the fraction didn't reduce, you just leave it as a fraction. On 13, Elena, what should we do first?
Are we trying to like push them together?
Mm-hmm.
So you can put the 3 on the end.
Okay, put the 3 up as an exponent of n. Then what? Now we can't solve this because these aren't numbers, but
You can do m over n to the -3.
no, it's into the third still.
Okay.
If you put it on top, it would be into the -3.
Okay.
But we're dividing by into the third. It just stays like that. Number 50, log of a equals to log of b. Alright, Ty, what can we do on this one? So we got log A plus log B squared minus log C cubed. Now what do you think?
You multiply the first two from there.
Yeah, AB squared. What do I do with this guy?
B squared over C squared.
Yeah, AB squared over C cubed. Yes. That's it. As easy as 1, 2, 3, A, B, C. Okay, 19, 19, 19, 19, 19. What do you guys think we should do on 19, or 17 rather?
Find the parentheses first. And then keyword.
We could do that. Probably not the best. What else could we do? Normally, what do you do with a number outside of parentheses? So we could distribute it. Let's do that. So what's 2 times a third? So we got 2/3 log of B minus 1/3 log of base B in minus 1/3 log base B of P. Okay, so the 1/3 is, that's a weird 1/3. The 1/3 has been multiplied out. Now what do we do with those numbers out in front? They're going to go up in the exponents. Oh, you know what? Yeah, that's the first one like this. Okay. I think they changed the exponents on this one to a radical, I'm pretty sure. Let me see if I can find the answer. Yeah, they did. Technically, you could leave it in rational form and it'd be correct. I don't know. We'll do what's a little bit though. Okay, so how would I write this divided by this divided by this? Any ideas? M to the 2/3 divided by N to the 1/3 divided by P to the 1/3. What should we do with that? Divided by P to the 1/3. Is the same thing as times 1 over P to the 1/3, right? So basically it just goes on the bottom with the divisor. So anybody want to guess how the book wrote this? Well, the third, if the denominator's a 3, what does that kind of translate into for exponents? Cube root, right? So it's the cube root of m squared over np. it say you had to write it like this? No, it didn't tell you how to put it in radical form, but that was the first one like that. Number 19. Log pi plus 2 log r. Is it warm in here? Is it me? You got a sweatshirt on, you should be warm. Are you warm? Alright. They kind of went back to easy on us, I feel like. So the 2 goes up here as an exponent. So this is log of pi plus log r squared. And then what do we do with the pi and the r squared? Just multiply them together. So it's log of pi r squared. You guys know what pi r squared is? Area of a circle, yeah. Circle area. What does that have to do with log? Nothing, as far as I can tell. Number 21. I don't know why they put the hardest one, 17, kind of in the middle. Alright, Crystal, you know what we should do first?
Multiply the first two.
You could. What do we normally do first, though?
It's the 1/2.
Yeah.
That's
And do you know what 9 to the 1/2 is? 3. So we have natural log of 2 plus natural log of 6 minus natural log of 3. Okay, so you said multiply these two, right?
Yeah.
2 times 6 is 12
Over natural log of 3.
over 3. Well, divide, right? So 12 divided by 3 is 4. Yoink. That might be a good stopping point. Well, once you guys have time to work on these evens. Go for it.